Here's part 2. So we are now looking at a t-table. And what you should notice when you're looking at the t-table is first that we're only given specific areas. So this right here represents when the area is, above the statistic is 0.1, 0.05, 0.025, and getting ever smaller parts of the tail as we move in this direction. As we move down the vertical, we're increasing in the number of degrees of freedom. And so the first thing to highlight is that the t value right here, which the t value represents the same thing that the z value does. It's your number of standard deviations away from the mean. That as the number of degrees of freedom increases, these decrease. And in fact, how far do they decrease? Well, they decrease to the point where when you get down here around 120, they're almost exactly the same as a normal distribution. And if you take an infinite number of them, they are the same as a normal distribution. So this would be the z-score for 0.1 above. Okay, on the bottom here, these are for confidence intervals. If you need a confidence interval, you grab this number right here. If you need the area above, you grab this number right here. So let's do 2 examples. First example. What's the score that goes with 0.9 of the data below? If this was a z that we were looking at, oops, that wasn't supposed to happen. If this was a z that we were looking at, then we can answer the question right now. Because it's a t, we can't. Here's our distribution. Here's 0.9 down here. Now that's not the number that you're going to use because the t-table gives you the data up here. So you're going to use 0.1 instead. What we also need are the degrees of freedom. So let's suppose the degrees of freedom are 15. Then we're going to go to our data set, or our t-table, and we're going to find 0.1. And then scroll down until we get to 15. The t-score that goes with that is 1.341. Skip the second one. And let's look at a 95% confidence interval. In this case, let's suppose that your sample size, n, is equal to 22. In that case, your degrees of freedom are always one smaller, I mean, it's n minus 1. So 22 subtract 1 is equal to 21. What we would do in this case is go back to the table and go to the bottom, and we want a 95% confidence interval. So this is this column right here. And in this column, 21 degrees of freedom is 2.08. So we're going to enter that on our in your notes. One thing I should mention is look how ridiculously large the numbers are up here when you've only got 1 degree of freedom. In order to be sure that you have only 1% of the data above you, you have to move almost 32 standard deviations to the right of the mean, which is, I mean, typically with a normal distribution, once you've moved 3, almost all of the data is below you. So this is really incredibly large, and it stresses the importance of having enough data to work with. So what was that answer again? Let's see, 95%, 21, 2.08. Okay, so t equals 2.08. I'm going to work through 2 examples of problems with you. And here's the first one. It's from your book. It's problem 11.9, and it's about vitamin C content. It's on page 628 of the book. Now, if you'd like to pause the video for a moment, what I want you to do is read the example and then put those 8 data values into your calculator. Okay, so let's assume that you've got an idea of the problem. We want a 95% confidence interval for the vitamin C content. So describe the population and the parameter. Okay. So our population is this, what is it called? CSB. Okay, is CSB, and our parameter is going to be the mean vitamin content. The important thing to talk about this in this case is the inference procedures. And the big thing that we should note is that we don't know sigma. It's not given to us. And as a result, what we have to resort to is a one sample. That doesn't mean anything right now, but we'll see 2 samples later. A one sample t procedure. One sample because you're getting one sample mean. The things we should always check, is it from an SRS? Yes, it says in the problem it's an SRS. Is it normal? Well, I looked at a normal probability plot and check. It was close enough. Okay. So now we actually want to work with the data. So you go to your one variable statistics and you come up with X bar. And the X bar is going to be 22.5 milligrams. Okay, and S, I'm taking this right off of the one variable statistics, is 7.19 milligrams. And the sample size is 8, which means the degrees of freedom are not going to be 8. They're going to be 1 smaller than 8. So they will be 8 minus 1 equals 7 degrees of freedom. Now, a confidence interval is constructed the same way it always has been. You take the mean, and then you add and subtract from it the margin of error, which is going to be, in this case, t star, since we're using a t distribution, times s over the square root of n. Which beckons the question, what is our t star going to be? Well, we know we're dealing with T7. We've got 7 degrees of freedom. And we know we want a 95% confidence interval. So this is where we go to the table. 95% confidence interval. Find where the degrees of freedom are 7. So that's happening right there. So 2.365. So our t star is going to be 2.365, or a little more than 2.3 standard deviations away from the mean. So our interval is going to look like 22.5 plus or minus our t-score times the sample standard deviation divided by the square root of the number of samples, which is still 8. That has not changed. When you simplify that, you get 22.5 plus or minus a margin of error of 6.1 milligrams. And so our confidence interval is from 16.5 to 28.5, and then we get the typical statement, and the statement reads something like this. We are 95% confident that the mean vitamin C content of CSB in milligrams per 100 grams is between 16.5 milligrams and 28.5 milligrams. And we know the true meaning of that statement is that if we ran this same procedure over and over and over and over again, 95% of the intervals that we get would actually capture the true mean, and 5 of them would not. Now I'd like to do one more example. I'm going to pause and then go to part 3.